Hi everyone, I couldn't be there today, but I will be here tomorrow and we'll talk more about what we learned tomorrow. So, today is chapter 4, day 8, proving triangles congruent by SSS. So, SSS just means side, side, side. So, on Friday for chapter 4, day 7, we learned about proving triangles by showing all three sides and angles are congruent. And that meant that we had at least 7 steps in our proof. Well, that's not going to be entirely true anymore. So for our first postulate, if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 sides are congruent. And by looking at our diagram, we have AB is congruent to RS, and we know that by the tick marks. BC is congruent to ST, and CA is congruent to TR. And so, triangle ABC is congruent to triangle RST. All 3 sides are congruent to each other. They're congruent triangles. We're not going to worry about the angles for now. So in our first example, FJ is congruent to HJ, and G is the midpoint of FH. So here in our diagram, it's already indicated that FJ is congruent to HJ. But it's also given that G is the midpoint of FH. If G is the midpoint, then it splits it in half. So we have 2 more congruent segments here. And we have to prove that triangle FGJ is congruent to HGJ. So in our proof, we always start off with what's given. It's easy, get it out the way. So FJ is congruent to HJ, and that's given. So that's 1 side down. We need to have 2 more sides in order to show that all 3 sides are congruent. So by looking at our diagram, what other sides are congruent to each other? Well, if we look at our tick marks, we have FG is congruent to GH. And that's because G is the midpoint. So if midpoint, then congruent segments. So that's 2 sides down. Now, what about our third side? Well, if we look at our diagram, we see that the 2 triangles both share this side right here, JG. So then we can now say that JG is congruent to JG. And that's the reflexive. Reflexive property of congruence. Now, we've proven that three sides are congruent to each other from two different triangles. So now we can say that F triangle FGJ is congruent to triangle HGJ. And we can say that because all three sides are congruent. Just write SSS and we are done with this proof. And we'll talk more tomorrow. If you have any questions, we'll talk about it tomorrow. So our last two examples. So decide whether the congruent statement is true or false and explain. So here we have triangle JKL is congruent to MKL. So JKL is congruent to MKL. So let's look at our measurements. We have 9 here and 9 there. And we also have, whoops. So we have 9 and 9, and we also have 8 and 8. And if you look closely again, they both share side LK. So these two triangles are congruent. This is a true congruent statement. Now, over here, it's a bit misleading, but don't let it fool you. Just look at the tick marks and see what's in common and what's not. So we have triangle RST is congruent to triangle TVW. RST and TVW. So it kind of looks like a right triangle. We don't know for sure, but it kind of looks like a right triangle. But let's look at the tick marks. We have 3 tick marks here, and we have 3 tick marks there. Now, they don't look like the same triangles, but it's just the 2 same triangles had this one being rotated. Okay, they're basically the same triangles, except this one's rotated in a different direction. And we have ST is congruent to WV, and we can also put that TV is congruent to RS. So yes, this is also true. Okay, they're the same triangles, except the one outlined in red is just rotated up more. They are congruent. And if there's any other questions, I'll be here tomorrow and I'll answer them all. Thank you and see you all tomorrow.